Here you're looking at core 1 of 6 of 38 of 15 west of the 4th. It's actually the only Cambrian core that we have out on display today. The formation we're tentatively assigning to the Mount White Formation, an offshore primarily unit that is in the Cambrian, and it does contain in the Rocky Mountains a lot of bioturbation in it, so it's quite interesting in outcrop. And this lateral equivalent, at least, even if it's not lithostratigraphically Mount White, shares some of those characteristics. It's heavily bioturbated, it has sand lithosomes and shale lithosomes, and it appears to be primarily deposited in a proximal offshore to offshore setting. This core in particular looks to be proximal offshore. It's got sand beds and mud beds. There's evidence for minor wave reworking, and there's abundant ichnofauna. And the Mount White Formation itself, remember, is below stratigraphically the Cathedral Formation, which is below the Stephen Formation and interfingers with the Stephen Formation. So this is older than the Burgess Shale. And this sample here we wanted to include because it shows one of the classic Cambrian trace fossils, Cruziana. And Cruziana is a trace fossil that's commonly associated to trilobites. Yes, other trace makers might be able to make Cruziana, but trilobites were certainly a common trace maker associated with the Cruziana. You can see these characteristic striae on two sides. They emanate towards a medial furrow. So how would you describe this trace fossil? We call it bilobate. There's two lobes. We call this a medial furrow. And you look at these traces and you kind of get the idea that the scratches go from the inside out, but the opposite is true. The scratches go from the trilobite or other arthropod, whatever arthropod it was, legs as it scratches inwards, as it uses its legs to propel itself forward through the sediment, and perhaps in some digging motion that'll help it get food as well. Kind of a grazing habit. So these Cruziana are very typical of Cambrian rocks, and in this large diameter core, this is really a nice example. So just look up at the core, you'll see the label Cruziana, and you can have a closer look at this. Also in this core are traces that I wasn't entirely sure how to classify. You can see they're on a bedding surface, so they're probably at a sedimentary interface or at the sediment-water interface. They emanate from a point and they tend to branch outwards. When you work in the modern, you see features like this quite often at the sediment-water interface, and these are the activities of worms or little bivalves that are reaching the sediment-water interface, and then they stretch their bodies out grazing at the sediment-water interface. And we call this interface feeding. Now, I was kind of hesitant to assign an ichnogenus or ichnospecies to these features because they're kind of chondrites-like, but they're not backfilled the way chondrites are. And chondrites are more three-dimensional. They're not always constrained to a sedimentary interface like these traces are. So I just think of these generically as interface feeding probes. It's a behavior that's commonly associated to sedimentary environments where every so often food falls out of the sediment-water interface in some abundance, maybe as the result of a freshet or some tidal scenario or something like that, and then the animals have abundant food to feast on. Another trace fossil that we've labeled in this core, and you can look at the bedding planes in this core for other trace fossils, and you'll find a whole bunch more simple tunnels and simple vertical burrows that we can assign to Planalites and Skelethos, and then larger lined burrows that branch like this. These larger burrows that branch, quite often when they're this size and we can see that they're three-dimensional, we would refer these to thalassinoides, but I've biased my taxonomy here to Palaeophycus. And I biased it to Palaeophycus because the common trace fossils of trace makers of thalassinoides aren't really observed much until the Mesozoic. So thalassinoides is not really associated to rocks these old. And since this is just a two-dimensional view and we don't see the whole trace fossil, I think I'm allowed a little latitude in my interpretation of which ichnogenera it is. Given the age, given the way it's preserved and the fact that it branches, I'm going to side with Palaeophycus, but under the full recognition that this might not be the right ichnotaxonomic assignment, just the best based on the data we have. When you see bedding surfaces like this, you'll also see dots like this. What are these dots? Well, these dots are vertical burrows that are being intersected by the bedding plane. Those dots are invariably scalethos or arenicolites. Ones that are commonly paired, and you might look at that as a pair or that as a pair, it's hard to say. If you see a lot of pairs in the core, you'd say, oh, these are arenicolites. And if you don't see much in the way of pairing, then we just interpret them as scalethos. There's also little horizontal burrows like there, maybe down here, that we would think of as planolites. So right on this bedding plane is at least 3 ichnogenera, and there's maybe more if we spent more time looking at it. One of us should be wandering around the core display, so if you have any questions about any of these or any of the other trace fossils you find in this Cambrian core, wave us over.